Cool. Recording is on. Can you all hear me / see my screen okay? Fantastic. Let's hear it. Laura, why don't you tell me what is iteration and when do we use it?
An iteration is when you want to go over an array multiple times to put out a new output with something different happening to it.
Not necessarily new output, but essentially we want to use iteration when we want to go through everything in a collection of some sort, right? Right now, all we've done that with our arrays, but we'll be doing this to other things later. Andrew?
Yeah, I was just going to say iteration is basically like doing the same process on each individual item in an array.
Right. So in Ruby, one of the tools that we use for iteration is going to be enumerables, right? We enumerate over something. And we've already kind of gone down this road of learning about enumerables with .each. And we can use .each to do a multiple, like all these different kinds of tasks. We can transform the original collection. We can use it to kind of grab just portions of the collection, or we can make a new collection based on the first one. And so each is what we kind of call the base enumeral. Like you could do anything that you need to with .each. However, Ruby does have some more purpose-built enumerables to kind of help us do our thing. So what we're going to do is that before we kind of get into enumerables, these new enumerables and other techniques, what we want to do is we want to think about like the enumerable syntax, what enumerables return, and when we want to use them, right? So when we think about things such as, let me make this bigger because there's no way you can see that. Is this a good size? Would anyone like this bigger? Please do let me know if it is. If you do need bigger, it is not a big deal to do so. Fantastic. All right. They don't seem to be any objections. So we want to think about syntax, return value, best use cases, right? And it's important as we go through these enumerables to kind of like think about like for every single enumerable we look at these two things, like what is the syntax of this enumerable, what is the return value, and the best use cases. Cool. So let's do this for each, right? And so when we use .each, we have some kind of collection, and we'll do each. And this is going to be a element. Code goes here. Code goes here. That's the block, and the block is what's going to be run for every single element of the collection that we kind of go through, right? So this is the syntax. The return value, well, for the return value, each returns the original collection. So in this example, whatever the collection was would be what gets returned. And the best use case would be when you're iterating over a collection and there's not a specific purpose built enumerable. Meaning there's not a enumerable that does like the one thing that you need to do. I will also say that like there are a lot of enumerables and I do not remember all of them. Like there are ones that you'll return to time and time again because they do common tasks, but there's not one that I just kind of like that. There's sometimes ones that I just don't think of. And so like it is perfectly cool. I think is generally appropriate. So like if I am just doing something, I don't know if there's a specific new report, I will just do it using each. And then after the fact, I'm like, oh, is there anything better? Right? You can't go wrong with knowing each inside and out. As we are, our expectation for you during module 1 is that you will you'll start off by solving problems using .each, and then as we progress, we'll start like using the more purpose-built. We'll rely on each lesson less, and then move towards the more purposeful ones. That being said, sometimes each is the best one in the case. Cool. All right. So kind of moving on, when we were learning about each, we remember that each will always turn the original array. And we saw that when we use each, we need to use a placeholder, sometimes called an aggregator, to preserve that return data value we were looking for, right? So if we were, let me take this. Paste this, when we do this, what we're doing here is that we have this original collection called numbers, and what this code is doing is like, hey, we just want every single number in this collection multiplied by 2 doubled. And so what we do is we have this aggregator, this doubles empty array, that when we iterate through this numbers collection, we're going to take that number, multiply by 2, and shove it into this variable, into this this doubles variable. And then if we want to do anything yet, we need to do a puts doubles like so, right? And so when we have methods of return values, we can convert this into an array. No, I'm sorry, use a method to do this. So we can do def double numbers and doubles equals empty array numbers dot two. Please do point out if I make any spelling or typos. They will hurt you. They hurt me, and they will hurt you too. So when we do this, and we have this method called def double, we have this numbers array equals 1, 2, 3. 1, 2, 3, 4, 5, and we do puts double numbers. What do you think we're going to get? Matt K. You are muted. Oh, there you go.
Yeah, sorry.
Sorry.
I was on the wrong screen. So looking at it, I would say it's going to take each number and then multiply it by 2 and then put it in the doubles array.
So, but what gets printed out to the screen?
It should be, I would think 2, 4, 6, 8, 10.
Okay. Who agrees? Who disagrees? Erica, what makes you disagree?
Each returns the original array. So because you're calling for that method, it's going to return the original array. You're not calling for the doubles array.
Yep. We need to remember that, like, two things here. One, in a method, the last line or last evaluated statement in a method is what gets returned. And so when we look at this double method here, each is the last evaluated statement. So, and as we know, because each returns the original collection, we're going to get that 1, 2, 3, 4, 5. What we need to do is that we want the last evaluated statement to return whatever we have whatever we're doing. So because we spent all this time like doubling the number and putting it into this doubles aggregator, this collector variable, we need to return that. So we do this, and we do this right here. And by having this doubles here, this is the last evaluated statement. This is what's going to return, and this should be that 2, 4 math, whatever the rest of those numbers are. Cool. Any questions so far? Cool. All right. Let us kind of move on to map. And so map is going to be our kind of like next step up enumerable. It's also known as collect. So the great thing about Ruby is that a lot of the methods, as you may have already kind of like surmised, you can kind of tell what they do, but what their name is, right? Each, like, yeah, that kind of makes sense. I'm doing for each of these things, I'm doing this thing. Map is like when we think about map. I don't really like map because it's just like, yeah, you're mapping over single things. Like that doesn't really kind of tell me anything. Like I'm mapping over things. Like how is that different from each? I like to think of it as collect. I think collect is a better name for it. It's like we are collecting things based on this original collection. However, when I write code, I'll always use map instead of collect. These two things are aliases. Like the map method does the exact same thing as the collect method. They are interchangeable. I just use map because it's 3 letters less typing. But in my mind, I think of it as collect. And so the difference here is that what each does is that it returns a new collection. The original collection, right? Like as we saw with this over here, like if each is the last thing, it's going to return this numbers that we did on it. What map does is that it creates a new collection and returns what we do in the block, right? Each will return us the original contents, whereas map is creating us a new collection. Right. So what we're going to do is that let's use, we saw each, and I think that this is a very common pattern with each, is where you have this original collection, this aggregator, and then you use each to kind of iterate over through a collection. But you in this, while you're iterating through, you are adding something to this aggregator, and then you have to return this aggregator. And this gets kind of like annoying because you have to make sure you're setting up the aggregator correctly. You have to make sure that you're returning the thing. And if you need to create something new based on the old collection, it does get a little messy. And so my dog has found a squeaky toy, and I have to confiscate it because you don't get a squeaky toy during class. Sorry. I thought I hid the toy well, and I did not. Where was I? We have this pattern of, let me put this up here so we can all see it. Right? We have this pattern where we are have a collection, have an aggregator collector. We do something to the collector with the enumerable, and then we have to do like a puts doubles. And this is very clear to understand, but again, we can kind of make this simpler. And what we would do is that we would use map, and it would look something like this. Let me just copy and paste this so it's all one place. We have this collection, and then what we do here is we do doubles equals numbers dot map do number. Oops. I need a O here. Number. This is going to be number times 2. And then we can do a puts doubles. So what map is doing is that it is going through for each item in the original collection. It is going to do a thing, and what it is going to create a new collection where each value of this new collection is going to be the return value of what happens in here. So essentially what's going to happen is we're going through. So the first time we're through, that's 1. Number times 2 is going to be 2. So we're creating a new collection where the first thing is going to be 2. We go through again. Number here is going to be 2. So we multiply by 2, that's 4. So now we are now going to put that 4 into the new collection. And so on 3 multiplied by 2, that's 6, that gets put in. And then that gets stored into doubles. Questions about map so far? Erica?
So you said it gets stored into doubles, and that's just now, right? So if you were to call like doubles on a different array of numbers, it would.
What do you mean by put doubles on a different array of numbers?
So like if you redefined the array numbers and then you called doubles numbers after that, would you get a new set of numbers? Like it wouldn't maintain the old set. It would just spit out a new one.
Yeah, so what we're doing here is that dot map is what we call non-destructive. It does not modify the numbers array at all. What it does, I think what we need to think about here is that like this equal sign is an assignment operator. When Ruby sees an equal sign, it will run whatever's in the right side, which is what I've selected here. Whatever that return value is going to put that into doubles. So we are never changing numbers here at all. We are just like whatever this numbers.map is returning, it gets put into doubles, and then we can put out doubles here.
Okay. So like it just returns it that one time, right?
Yep.
It doesn't like keep it
Yeah,
forever.
and
It just
in a
gives you the
second,
return.
yeah, in a second, we're going to put this into a method so you can see a little more clearly how that works.
Cool.
Cool. Laura?
So are you essentially just doing each, but not having to create a new array variable, empty array, and then having to not shovel it in?
Yeah, essentially
That's the
what
same
map
thing.
does is it's very similar to each, but what it does is that it takes that step of creating that collector, that aggregator for us. And what it'll do is that it'll create a new collection with the return values of whatever's inside the block.
Okay, and then if you were to put like puts numbers at the bottom where you have puts doubles, it would do
1, 2, 3, 4,
doubles
5.
and then numbers. Okay, cool.
Yep. Yep. Remember, like map does not change the original collection. Yep. Cool. Ida?
That was kind of my question, what
Cool.
Laura just asked.
Cool. So we've done this here. So let's do the same kind of thing as we did each. And what we're going to do is that we are going to use a method to do so. So we're going to do the same thing. Def doubles, going to take that numbers, right? And we do doubles equals numbers.map to number 2, and we have numbers equals 5. So we puts. Let me do this, and we can see side by side the difference. Cool. Notice how here we can actually kind of we can actually take this out and do this because stop. We don't need to assign to a variable because this is the only statement in this method, and it's what gets returned. So we can see how much this is cleaner than using .each. We have no need, we are using less local variables because this is the only thing, and the only thing that's happening in here. Ida?
Is the method name the same? Because on line 6.
Yeah.
Okay.
Thank you. Did I make any others? Yeah, I don't think I made any other spelling errors. Thank you for catching that. Right. So we see here using each, we have to create this aggregator. We then iterate through over the collection and put things into this aggregator, and then we have to return that. We have to return this the aggregator. Whereas using the map pattern, what we're doing here is that map creates a collection that consists of the return values of the block here, and because map is the only thing being run, that gets what returned. And so like these two pieces of code are functionally identical. They do the exact same thing, you get the exact same result. This is a little preferred because it's a little cleaner, it's a little easier to read, is a little more efficient because you are not creating an extra local variable and then returning it. And once you get used to like understanding what map does, it makes it easier to read. Any questions about map at this point? Cool. All right. What we're going to have you do is we're going to take 10 minutes and I'm going to put this in your code help channel. I'm going to put you in breakout groups, and you'll get some practice converting this to use map instead. So let me do 10 minutes. And off you go. You'll be working with your same best friends from before. Resume recording. Fantastic. Cool. So I kind of like set up a framework here. Caitlin, what did you get? What should I be typing in here to get this to work using map?
I was working with Kelsey.
Uh-huh.
And, so what we had done is started off with the mapping after the array. So brothers.map.
Huh? And what did you call your block parameter?
Brother or name.
Cool.
And
And what
then,
do I type in here?
so knowing that the map returns the new array, we had each name passed down and we wanted to capitalize it.
Upcase.
Okay, so yes.
Yeah, capitalize does something different. Capitalize literally capitalizes it. Yeah, it's fine. Cool. Yeah, and that's it. Great. Cool. That is a thing. So as you come back from the break, any other questions about map? Pretty
Now that
straightforward.
I've seen map and what that does, like why would we ever want to use each?
Because sometimes you don't need to modify the collection. And also because like each is just a generally good starting point if you're not sure which new rules to use. There are instances where you will not need to create a new collection. All right. Cool. Next up, is going to be find attack. A lot of the numerals in Ruby will have two names, like find and attack, and both will work. The reason for this is that Ruby was designed to kind of attract people from other languages and make other people from other languages feel more comfortable. So like the same kind of functionality will the same kind of functionality that other languages do, they'll call it the same thing, and like they just want to make it like easy, like the name. And another good thing about Ruby is that like you can pretty much figure out what a method is going to do just by its name. Like, what do you think find does? Like, it's, I mean, like one of my biggest pet peeves is like defining a word by using the same word. And so like, what does find do? It's going to find something. Like, yes, you're right. You're not wrong. But what find will do is that it will return the first item from a collection that evaluates as true, as truthy. So what we're going to do is that I'm going to do this. I'm going to show you what this looks like by using each. Find first even, and we're going to have numbers equals 1, 2, 3, 4, 5. Right. And essentially what we want to do is that we want to find the first even number. So this, what we want is we want this method to return us 2, right? Because in this collection, because we're going in order in this collection, we want the first even number, and that is going to be the 2. So what we do with each is we do numbers dot each do num if num dot even. Nope, let's do it this way. Return num if num dot even. And this is what's called, this kind of particular syntax is what's called a guard statement. It's kind of checking of this thing. And what happens with things structured this way, with this return explicitly written like this, is that it will kind of halt execution of this iterative loop if this turns true. So what it's going to be like, okay, cool. We're gonna let's kind of walk through what happens, right? Numbers that array 1, 2, 3, 4, 5. We're going to go through each one. The first time through, num here is going to be 1, right? And so we hit this line where num is going to be 1, and Ruby sees this line: return num if num of even. So what it's going to do is that it's going to look to the right of the if, and it is going to evaluate what happens to the right. Num.even, 1.even, is 1 even? No, it is not. So because no, it is not, this side is essentially the same thing as false. So the left-hand side does not happen, and it moves on to the next number. So it pops back up again. So now the second time through, num is going to be 2, right? And so we go back down here, and it's going to, it's going to see return num if num.even. And what's going to happen is that it's going to look at the right hand side first. It's going to be num.even. So num is 2. So 2 is it's asking essentially, is 2 even? 2 is an even number. So the right hand side of this statement is true. Because the right hand side of the statement is true, the left hand side happens. And when we return num like this, that means it's going to, the explicit return means that we're going to, okay, we're going to stop. This whole method returns 2, and we're done. Any questions about this so far? Right. So what we've done here is that Isaka?
So, and it doesn't go through the whole array because, there are 2 even numbers in that array, 2 and 4.
We just want the first one.
So you said, right, so we want the first one, but because we use .each, isn't that supposed to go through the whole array?
Yeah, but what we're doing here is that returning num like this is going to kind of like break it out. It's going to stop as soon as this hits.
Okay. But if we don't have the word return there, it will basically go through the whole array, correct?
Yeah. Mm-hmm.
Okay, thank you.
Mm-hmm. Weston?
So this is more a question about general or about best practice when it comes to conditionals. What case would with if statements we learned yesterday, we did multiple lines, but why would you use a single line instead of a multiple line or vice versa? Default?
Because this is just a single situation that is only one branch, I would use the guard statement, because it's essentially saying like, hey, in this one case, I want you to break out. If not, I just want you to proceed as normal. This is just like the kind of one instance. Like, if this is more complicated, if there's others, I would use a full-on if-else kind of statement. If else, else if, the whole thing. Cool. Good questions. So, I mean, this is fine, right? It's fine. But what we can do is that we can kind of clean this up a little more by using a purpose-built enumerable. And so what we're going to do is that underneath, I'm going to do the same thing. Def find first even, and we're going to do the numbers equals, equals 1, 2, 3, 4, 5. And what we're going to do is that we're going to use the find enumerable instead of using .each, and you'll see that this does clean up a little bit. Numbers.find, do num.even. And so this will return us that too. But what is happening here is that for whatever num, whatever in the block returns true for or truthy, it will just stop and take whatever this num is and return that. So what's going to happen? Let's just kind of go through here. We say 1. Okay. It goes through define is going to be okay. The first one's 1. Is 1 even? 1.even? That's false. Cool. We don't do anything. We go to the next one. 2. We come back in here. 2 dot even, right? Is 2 even? Yes. Cool. That means that this block here, the return value of the block, is going to be true. And then now it is going to return whatever num was when this hits true, and then it's going to stop. It's not going to go any further, right? What find does is that find will look for the first condition to be true and return that thing. It does not keep going and looking for more after it finds a thing, right? It's just going to like find that thing and stop. It's kind of like, I use this analogy a lot for like search optimization. And this is like my favorite. This is not my favorite. It's my favorite thing to kind of harp on. My least favorite saying is like, it's always in the last place you look. I'm like, of course it's going to be in the last place to look. When you lose your keys and you find your keys, do you keep looking? Like, no, you found your keys. It's ridiculous, right? And this is the same thing. Like, as soon as it finds the thing it's looking that thing that matches this criteria, it will stop looking and will do the thing. Questions about find? Isaac?
Could you please run the code for us to see? Because I'm trying to run it on my screen and it didn't work. Starting from the first example, numbers.each.
Yeah, let me copy and paste this into a pry because I have other stuff typed in here, right? Oops. Yep. Oh no, that didn't work. Let me do this. What I'm going to do is I'm going to comment this out. And then I am going to do a let's find first even. Cool. And we see it gets to the 2. Is this big enough? Let me make this a little bigger. Sorry, my window. Cool. Do you see that?
Yes, thank you.
And then what I'm going to do is that I'm going to comment this out. And I'm going to uncomment that. And we're going to do puts find first even. Oops. I can't use the excuse anymore. Last summer I bought a split keyboard, and I'm still learning how to type on it. It's better for my hands, but like 2 again. Cool. Was there another hand that I missed? I thought I saw 2, but like if I was just hallucinating and making things up in my mind, that is cool too. Matt?
So let's say instead of like numbers, you had like a list of names and you're looking for James or whatever.
Yeah.
What would you type for the find part?
Oh, inside the block? I'm gonna just copy and paste that because I just have a list of names right there. And oops, no. I'm gonna put that at the bottom so we have this to work with. If I wanted to find the first Ted, brothers.find do brother brother equal Ted. And this should return me a Ted. But it doesn't really make sense, right? It's kind of like, well, of course you're going to get a 10. That's what you're looking for. But let's do this. Let's see Alphonse, right? If it doesn't find it, it won't return us anything because it doesn't find a thing at all. But the thing is that we can also do other kind of cool stuff in here. Like we are in programming, like the sky's the limit. We can do whatever the heck we want. So what if I wanted the first brother whose name started with R, right? So we do brother, one way to do it, brother 0 equals R, right? We're saying like, hey, the first name that starts with R, and you could do any other kind of criteria you want. It just needs to be some kind of conditional that will return true or false, right? Because that's what find is looking for. Cool. Good question. All right. So what we're going to do is that we're going to break you into groups again. And what we're going to do is that I would like you to take some code. And I'll put this in your Slack channel. I'm going to give you 10 minutes to do this using each and then using find. Get the first sister's name whose name is longer than 4 letters in length. Longer than 4. Any questions about this? Grabbing the first sister's name who's longer than 4. You're going to be doing this each, and you're going to be doing this with find. And so, for the record, you should get Kathleen. So we're all on the same page. Cool. We'll take 10 minutes to do this. I'm going to put you in your breakout rooms, and you're off. Cool. Let's see here. Aaron, what did you get for the first part? Each. How would I do this using each?
Yeah, so for the first part, Blake and I did. Sorry, I'm just like looking back at it really quick.
Sorry.
So we had sisters got each do. And then we had sister for the block variable. Enter, and then we did return sister if sister dot length is greater than 4.
Excellent. And what did you do for find?
For find, we did sisters dot find do, and then sister was a block variable again. And then we did sister dot length greater than 4.
Great. Fantastic. Thank you. Any questions about find? Cool. Right. Where are my notes? I lost my notes. I lost the one. There we go. Fantastic. If there are no questions, let us move on to the next one, which is called find all. And again, amazingly, we can kind of figure out what this does because Ruby chooses to name things in a way that makes sense. I also want to mention that so find, the other name for find is detect, and the other name for find all select. I never use select or detect because they rhyme and it's very difficult for me to remember which one does which. So for me, I always use find and find all because it's very clear to me in my head, which does which. I know that find all gets me, well, as the name says, find all will get me all the things that match, whereas find gets me just the one. To be fair, when I think about it, I don't really know what find does. I just know that find all gets all of them, and find must do just one because it is not find all. And that's how I remember everything in there. Cool. So find is what we use when we want to get one matching thing, but find all is what we want to do when we want to get all the matching things. So I'm just going to copy and paste this out of my notes because you don't want to see me type. And this here is essentially, we're doing the opposite of what we did before. Before, we wanted to get the first even number. This one is what do we do if we want to get all the odd numbers? Right. And so essentially we're saying hey, we're going to iterate through all the things. And now we're using this collector, this aggregator result, and we're going to put the number into the aggregator if it matches our criteria. In this case, it is what if it's odd, and then we return the result. Questions about what we've done here with each to grab all the odd numbers? And we can see that there is a pattern to these enumerables and how they work. And the more we talk about enumerables, the easier it is to kind of wrap our heads around it. Right? So we do this, it's okay, so what if we wanted to make this so that we use find all? Well, let's delete this. And so when we talk about it, find all returns us a new collection of the things from the original collection that match the criteria. So what we're going to do is numbers dot find all do num, and what we're going to do is that we want all the odd numbers, right? So we're going to do num dot odd, like so, and this will give us 1, 3, and 5. Let me save that. Let me run it. Let's all the odds. We find all the RB, and we see we get printed out to the screen 1, 3, and 5. Yeah, find all, select, whatever you select. Ted?
This is like on topic, but a little like just it's like when I'm trying to like find new enumerables or like looking through the Ruby docs. Like I just looked up find all like on the docs right now. Like, do you have is it just me? It's hard to like read the docs. Like
yeah.
Why
so because writing good documentation is a good skill on its own. Ruby enumerables docs. So what I'll do is that I'll see this. Well, Ruby 301. Cool. And this is usually my process if I need to find a new enumerable. What I did was that I made this my homepage on my browser for a long time because like I was bad at enumerables. And so if I need to do something, first thing I'll do is that I'll go over here to the methods and I'll just scan them and I'll look for anything that kind of like sounds like it does what I want it to do. It's like, yeah, chunk. I don't know what that does. Like we have find all. Yeah, cool. Min by, one none, one reject, sort, and I'll try to find something that's close to that. But let's say, for example, we're looking, we don't know, find all. Like find all sounds like what we want to do, right? We click on this and you're like, oh, that is a thing. And we have some code here. And it's like contains all, like this is not exactly what I would say like the most user-friendly readable, right? So I would usually go look at this and try to make sense of it and like, okay, so find all, like I say, okay, this looks like for things that are divisible by 3, even numbers, whatever. I also see reject to grep. Like looking at reject, I can probably assume that like reject feels like the opposite of find all. Of like it'll look for things where the thing returns false, right? But like I want to know about find all. Find all is close. So what I would probably do is Ruby find all blog post. And then we have here blog posts. And I generally, if there's a method I don't know how to use, I would try to make sense out of it using the Ruby docs, and failing that, I would look for blog posts. Because blog posts are generally written by people that want to explain things in a very English language friendly kind of way. And so like, hey, Ruby find all versus select, what's the deal? That sounds like something that I could read and probably understand pretty easily, And so it's on Medium. So like, yeah, cool. This person went to Flatiron. Good for them. This is like the worst part. It's like, sometimes blog posts are kind of like those recipe blogs. I'm like, I just want the recipe. I don't need to know about your culinary journey, how you traveled here for a month, and figure like, no, let's just skip down. Like, I appreciate the Kramer, but like, cool. Like halfway down is probably where you really want to start reading. And we can see like a little more better English friendly explanation of it. So usually that's like my process if there's like a enumerable I want to use. And the thing about enumerables is that they keep adding more. And so like, if we go up here and look like, yeah, I forgot which ones, but I know they added a couple in 2.7. Each cons is relatively new, I think. Drop while and drop while are relatively new. So like you also be sure that you're using the right version of the Ruby docs and on your computer when you're looking for things. It's very rare they'll take away enumerable, but they will add more. So does that help with like deciphering Ruby docs? Yeah,
Yeah.
like this is not the best thing in the world, but like it's a good starting point, because like we know that here in the root docs for this here, we know that this is a definitive list of all the numerals we have. And then like we find one that kind of sounds like it does the thing we want, and then we go from there. And then you'll have to read someone's adventure, but skip to a third to halfway down, you'll find the good stuff. Cool. Bum, bum, bum. Fantastic. Cool. Any questions at this point? Cool. I'm going to send you off to your groups again. Right now, you are going to find all the numbers that are divisible by 3. And I would suggest, if you are unsure of the process to do that, look something up called the modulo operator. And I'll put that in your Slack wall so you have that. Let's take 10 minutes to do this, and we'll see you in 10. Where's my breakout window button? I've lost it. Let's just, oh, there we go. Cool.
Did you want us to do this with both each and with find all?
Yes, yes, with both. Each, then the find all. So you get a feeling for both. And off you go. Resume recording. Okay, I'm going to show you how to think because I want to make sure we have time for questions. So find all numbers divisible by 3 using each. We would do 3s. Do numbers dot each do num. And so using the module operator, essentially module gives us the remainder of a thing. So what we would do is like, so for example, just make an example here. Oops. If we had 3 modulo 3, this would be 0, because the remainder 3 divided by 3 is 0. Whereas if we had, let's say, 5 modulo 3, this would be 2, and 2 is not 0. And so essentially, when we modulo a number by something and the thing is 0, that's going to say it's divisible, means what's divisible by. Oops. So here we're going to do num, and we're going to do please if num modulo 3 equals 0. And we would do using find all numbers dot find all do num. Cool. Any questions about find all? Cool. Any questions about numerals at all? Cool. So these are just like 3 as you've seen many more numerals in the documentation. We're going to cover like the more pertinent ones throughout your time here at Turing, but not all of them. And so like it is probably a good habit to get used to the syntax of various numerals and try to like tease out like how do I get the thing to do what I want to do. But that's it for this morning.